So let us discuss today lecture number 6. In this lecture we will be going through the numerical problems which are based on ultimate stress, factor of safety and bars of varying section, as well as the application of principle of superposition. Now numerical number 2, which is based on ultimate stress and factor of safety. So you are aware after going through the stress strain graph that what is the meaning of ultimate stress, what is breaking stress, what is elastic limit, and all the terms are related to them. So statement for this numerical number 2 is a hollow steel column is subjected to an axial load of 1.9 meganewton. So load is given 1.9 meganewton and the column is hollow cylindrical column. External diameter of the steel column that is given, which is mentioned in the numerical, and the ultimate stress of the column is 500 Newton per millimeter square. We will be taking a factor of 55 and we have to work out the internal diameter of the steel column which is subjected to this type of loading and from the data available. Now you can see this will be a sketch of that is a hollow steel column, and you are able to see that this column will be having some height as well as internal diameter and external diameter. Because it is hollow inside, so it will be having two diameters, external diameter as well as internal diameter. Now regarding solution, first of all, as we have discussed the methodology of solving the numerical in the numerical problem 1, first of all we will be list out the data available in the statement. So ultimate stress is given 500 Newton per millimeter square. Axial load is given 1.9 meganewton. So that means we will be converting it into SI units, 1.9 into 10 raised to power 6 Newton. Internal diameter, let us take it as D1, which we have to calculate. It is not given, so that is the problem which we have to solve. External diameter, let us consider it is D2. It is 200 millimeter. So that means what will be the external diameter basically? If you calculate, that means this much diameter will be external and this diameter will be internal. So it has two type of diameter which we will be considering. Factor of safety we are taking here 5. Now factor of safety mean, from factor of safety we will be able to find out what will be the safe limit of the stress which this column can resist. So that means this is the ultimate stress, and after dividing this ultimate stress by factor of safety, so we will be getting the safe stress or the limited stress up to which this column can be subjected to, or that will be the property of the column. Now factor of safety, as I have told, it is the ultimate stress divided by permissible stress. So ultimate stress belongs to the property of the column, that means from which material it is made up. From that you will be able to get the ultimate stress, and permissible stress is, by taking into consideration safety, we will be considering the permissible stress will be less than the ultimate stress, so that due to any accidental reason it should always remain in safe condition. So from this permissible stress will be worked out, that is ultimate stress divided by factor of safety. So ultimate stress is 500 Newton per millimeter square. Factor of safety is 5. So you will be able to get that permissible stress is 100 Newton per millimeter square, which I have mentioned. It is the maximum stress which is allowed. That when in practice, when load is coming on the column, it will be under stress and only this much stress is allowed. So we are not stressing it up to ultimate limit, but we are stressing, or we are allowed or permitted to stress it up to this only 100 Newton per millimeter square. So this is the difference between, first of all, we have understood that what is the ultimate stress and what is factor of safety and what is permissible stress. So relation between permissible stress and factor of safety we have gone through. Now next step is, as the formula for stress is load upon area. So whatever the load you can apply and what will be the area. Now since it is a hollow cylinder, so area of hollow cylinder will be outer area minus inner area. That means outer cross sectional area minus inner cross section area. Why? Because material which is available is only available in this much area, because inner area is hollow, so it will not be able to take any stress or any load. So whatever be the material from which this cylinder is made up, that is outer area minus inner area. So whatever with this area, that will be basically the material contained in the cylinder, and that material will only take the stresses. So formula will be again same, pi by 4, that is d2 square minus d1 square. D is diameter here, d2 is the outer diameter and d1 is the inner diameter. So using the formula, it's a very simple numerical type of problem. That means this will be 100 will be the permissible stress. So permissible stress is equal to load upon area of the column which will be able to resist the stresses, which will be able to carry the load. So from this calculation you will be able to work out that D1 is equal to 125.68. Now what is D1? D1 is the internal diameter which is not given, so that we need to calculate. So we have calculator. So D1 in millimeter is 125.68 millimeter. So if we from conclusion from this numerical we can conclude that if the diameter, internal diameter is 125.68, then it can resist the axial load with a factor of safety. Now if we want to analyze or discuss the problem, that means if D1 is, suppose you are decreasing D1. Now suppose D1 is 100 mm, then what will happen? Will its load carrying capacity increase or will its load carrying capacity decrease? So note down this question. That means if D1 is 100, then what will be the effect on the load carrying capacity of this cylinder? And if D1 is suppose more than 125, that is if D1 is more than, that means earlier D2 we have taken 200, external diameter we have taken 200. So that means in second point which I want to discuss, that means if you take D1 more than 125, that means suppose let us take it is 150 mm. So first case 100 mm and second case 150 mm. Then you have to work out what will be the load carrying capacity, whether load carrying capacity increases with the increase in diameter, internal diameter, or whether load carrying capacity decrease with the increase in the internal diameter. So that is a question for all of you. You can work out and you can give your comment in the comment section. Now second problem, that means problem number 3. Now this problem number 3 is based on bars of bearing cross section. Now if you seen in this numerical, the cross section area throughout the length of the cylinder is same. But if we are changing the area, that means there is a one element but it is having different area of cross section, so cross section area is varying, then what will happen? So that type of numerical problem we will be solving in numerical number 3. Now statement is a steel bar as shown in figure. Let us go through the figure. Before that, we just understand the statement. A steel bar as shown in figure is subjected to tensile force. Now whatever the force acting on the that a steel bar is given 160 kilonewton. So if the safe stress in the middle, now let us first of all go through the diagram. Now this is the diagram. You can easily see here, you can understand that diameter of this much portion is 6 centimeter. Diameter of a middle portion is not given, that is we have to solve it, and diameter of the other end section is 6 centimeter. So that means section here is 6 centimeter, here section decreases and then section again increases, so it is a varying section. So in the problem it is given that the length of this whole sample which is under tension is 40 centimeter. Nothing else is given in the statement. So if the safe stress in the middle, it is given that this middle member has permissible stress 150 Newton per mm square. That means if a stress in this middle member increases for more than 150 Newton mm square, then it will fail. So this is the ultimate, not ultimate, safe stress basically, which we can permit. Ultimate stress may be more than 150. Now determine the diameter of the middle portion. So we have to find out diameter of the middle portion, that is D2. It is also mentioned that the total elongation of the bar. Now it is given total length of the bar is 40 centimeter. That means 400 millimeter. And total elongation when it is subjected to some axial force, it is given 0.2 mm. So first of all, this D2 is not given, which we have to calculate. Second point is calculate the length of the middle portion. So here we have just consider or assume that this length is L1, taking end portion of equal length. So it is given in the statement that length of the end element is equal. So, but we have to calculate the diameter of the middle portion as well as the length of the middle portion. And the Young modulus of elasticity is given 2.1 into 10 raised to power 5 Newton per mm square. So first of all, again, same methodology, data available. Safe stress is given 150 Newton per millimeter square. This safe stress is for middle section. Tensile force, which you see this black color, that means tensile force is outward force. It is 160 kilonewton. Diameter of end portion is given. So diameter of end portion is 6 centimeter. We have converted into millimeter because we will be taking same unit throughout the numerical problem to avoid any type of error. So D1, let us consider D1 is the diameter. Diameter middle portion, as already discussed, that we have to calculate. D2 we have to find out. Another thing given is total elongation. Suppose it is delta L, so it is equal to 0.2 mm. So we have two type of information which we have to calculate. First of all, we have to find out the diameter of the middle section. Second, we have to find out the length L1 of the middle section, and this much data is available. Young modulus is given, yes. Now, let L1 is the length of the middle portion, as we have already discussed. Length of the end portion will be definitely, if we consider that length of this portion plus this portion is L2, then L2 will be 400 millimeter minus L1. So up to this almost data is available. So we have to go through the details. Let us go through the calculation part. Now what we have to calculate? If we just try to understand that how do we have to solve, first of all, very important data, safe stress is given. So safe stress is 150 Newton per millimeter square. Now safe stress will be load upon area, but area is not given, only diameter we have to find out. So let us do step by step. Area of end portion will be given by this formula. Area of end portion is 900 pi because it is 60 millimeter. Area of middle portion, you have to use this formula, pi by 4 d2 square. Then stress in case of middle portion, that is load upon area. Area here means cross section area of the member. Stress is 150, so we have taken it as 150. Load is 160 kilonewton, so we have multiplied by 1000 to make it a Newton divided by area. So very easily you can find out diameter. So diameter of the middle portion is 36.85 millimeter, and from this you will be able to calculate the area. So a cross section area of the middle portion is 1066 millimeter square. It's very simple. Now calculation of elongation basically. Why? Because we have to find out. Now D2 we have calculated. Now L1 we have to find out. To find out L1 we have information. We can use this information of total elongation. So what is total elongation? Total elongation will be elongation of middle portion L1 and elongation of L2. L2 is this plus this. So here you can use the formula of elongation, that means delta L. How to find out delta L? So this formula you can use delta L P upon E. Basically formula for delta L is PL upon AE. Here L1 for this portion, A1 area of cross section, L2 total length of the end portion, area cross section. So easily you can calculate that L1 is coming out to be 207.14 millimeter. So this was 400 millimeter. Total length is 400 millimeter. 40 centimeter is equal to 400 millimeter, and middle portion is 207.14. So this was the another type of problem where section is varying and all the other information is available. Now problem number 4, that means numerical number 4, which is based on principle of superposition. Statement. Let us go through the statement. First of all, a member with element of varying cross section. So it is just similar to the previous problem. Preliminary information is subjected to load as shown in figure. We will go through the figure. Okay, so we will go through the data. Calculate the it is not visible. Required to keep the member in the state of equilibrium. So some force is required. Let us go through the information available. It is given P1 45. So when you we will be going through the diagram, you will be able to understand what is P1 here. Okay, now let us go through the diagram. Now you will see here, this is a member having varying cross section area. If you see, this first portion is having area of cross section 625 millimeters square. Now directly area is given, diameter is not given. Middle portion is having area 2500 millimeter, and third portion is 1250. So this is a classical example where cross section area changes or varies with the length. First portion is having 120 centimeter, middle portion 60 centimeter, and 90 centimeter is the third portion. So this diagram will be given in the numerical. It is given to us, and P1 force is acting here, P4 force is, P2 is acting at this junction, P3 is acting at this junction. So ABCD, you can say it is a member and four type of forces are acting. P1 is given, P3 is 450, P4 is 130 kilonewton. Young modulus of elasticity is given 2.1 into 10 raised to power 5 Newton per millimeter square. Now here what was not visible basically, we have to calculate this P2. Now what is the condition? Condition is clearly mentioned that for equilibrium, it is said that for you have to calculate the value of P2 so that the member will remain in the state of equilibrium. Now what is equilibrium? Equilibrium means there will be, you can say, no, or in other sense we can say that summation of all the forces is equal to 0. So how many forces are acting? 4, 5, etc. If you sum up all the forces according to their direction, according to their sign convention, you can take sign convention for tension as plus and for compression as negative or whatever, or vice versa you can take. Now for equilibrium, summation of sum of all the forces along x direction, because forces are acting only along the x direction. If we consider that this is x direction, summation of forces along x direction, what we have to find out? We have to find out what is the value of this force P. So what is the value of this force P, which will be responsible so that whole of the specimen or member will be in equilibrium. So let me remove it. Okay. So when you sum up all the forces, suppose P1 is positive, then P2 will be negative, P3 will be positive, P4 will be negative. That means if tensile force is positive and compressive. Now this is tensile force, it is acting away from the member, and this P2 is on BC member, it is compressive, P3 is also compressive, and P4 is tensile. So sum of the tensile forces is equal to sum of the compressive forces, which will be summation. Sum of all these forces will be equal to 0. That means P1 plus P3. That means similar type of problem which are acting in the positive x direction as well as negative. So P2 and P4 are acting in the positive direction of x-axis. P1 and P3 are acting in the negative direction. The sum of forces along the negative direction is equal to sum of the forces along positive direction. So they will sum up to give the resultant 0. So we can say it is the case of equilibrium. So from this equation, by putting all the values, P2 is worked out to be 365 kilonewton. So this first question we have solved, and at last you have to find out, also determine the total elongation of member, assuming modulus of elasticity 2.1 into 10 raised to the power 5 Newton per millimeter square. So we have to find out the total elongation of the member. Here you can use the principle of superposition. Now principle of superposition states that total extension will be equal to extension of all the members, taking into consideration their sign. Now what is the meaning of sign here? Now if P1, suppose this AV member is in under tension, so that means there will be elongation. BC member will be under compression, there will be, you can say, contraction. So length will decrease. This for this member AB there will be extension, for BC there will be compression, and for CD there will be extension. So we have to sum up all the values. Let us consider extension. For extension delta L is positive, for compression delta L is negative. So we have to find out total elongation delta L, and for this we have to draw the free body diagrams. Free body, we will be considering that each component of this member is in the state of equilibrium. So what we are doing, we will be first of all try to draw the free body diagram. Now what is free body diagram? Now free body diagram of, let us consider it as a junction A, junction B. Suppose this is member AB. Cross section area is given, P1 force is given. Now let us consider this P2 dash, because this is the second point. P2 dash is the force which will keep this member in equilibrium. Okay, so this member will remain in equilibrium. And when we draw the free body diagram of this BC member, what you will observe, we can say here P2 double dash force is acting. It is what I want to say, that this force P1 P dash 2 plus P double dash 2, they will sum up to give the value equal to P2. So that means we are dividing this P2 force into two parts. Okay, P2 is acting in the right direction, so we have divided into two similar forces in the right direction so that their sum will be equal to P2. Similarly, now P3 force is acting at junction C, so we have considered it as P-3, and for the member CD, you can consider it as P-3, similar to the previous case. Here P-3 plus P-3 will be equal to P3. So P4 is the final force. So these three members, actually we have divided a member into three components as per their cross section area. So we can easily understand it and we can solve the problem based on the principle of superposition. Now as I have told you that P-2 plus P-2 will be equal to 365. From where this 365? This 365 is given. How it is given? Now P3 is given 450. This P1 is given 45. P2 we have to calculate, and we have calculated in the earlier section. First point, that is 365. So P1 is acting here 45. P2 is 365. So P-2 plus P-2, sum of these two forces is equal to 365 kilonewton. Where P-2, now I have told you this is this AB member is in equilibrium. It can be only in equilibrium when P1 is equal to P-2. So P-2 is equal to P1 is equal to 45. From where this 45 came? Because P1 is 45. So it is very much clear that P2 dash plus P-2 is 365, and from this calculation you are able to find out P-2 is equal to 320 kilonewton. So now let us discuss this member BC, that is free body diagram of this portion BC. Here two forces are acting. Now if this member has to be in equilibrium, then what will happen? From this third diagram, this member will remain in equilibrium. So here what are the various type of forces are acting? You will get this P4 force. P4 force is 130 kilonewton. It is acting, and this total P3 force is 450. Now P3 force is 450, P4 force is 130. So that means net force will be 320. That means 450 minus 130, that is equal to 320. So 320 P-3 is equal to P4, that is equal to 130. So we have calculated this force because P4 was given. So P4 will be equal to P-3. So P-3 is coming out to be 320. Again solving, just like in the earlier problem we have solved. Now as I told you that suppose delta LAV is the extension or compression, but this member is under tension, so it will be positive. So by using the formula from the previous problems, delta LAB is worked out to plus is for extension 0.4114. Delta LBC, now it is under compression, so there will be compression. So that's why we have taken negative. So delta L in BC member is negative. and delta LCD, because it is again under tension, so it is 0.4457. So summing up all these, you will get the total elongation of this member which is subjected to this type of forces, number of forces and varying cross section is worked out. Positive mean net extension will be increase in length of the whole member. So it is 120 plus 60 plus 90. Now at the end it will increase by 0.4914 millimeter. So this is the third, or you can say fourth type of problem where we have used principle of superposition. We have gone through the free body diagram concept and we have gone through the equilibrium condition. So whatever be your queries, you can point out on in the comment section, and I suggest to you you should go through number of these type of similar type of problem so that you can understand all these concepts clearly and comfortably. Thank you.